Welcome to the session about low light performance. Low light performance is one of the key image quality aspects of today's cameras, I would say. So a lot of mobile phones are capable to capture good to really good images in bright light conditions. But the differences occur when you go into low light. There are many devices today that are capable to capture acceptable image at as low as 1 lux. But how to actually measure that, how to evaluate that. So there is an ISO standard that describes this measurement procedure, and I would like to give you a little bit more insight how this works. So there is ISO 19093 that contains the measurement procedure and the test protocol about low light performance. At the end, it will tell you at which lux level you still get an acceptable image quality out of your device. It is designed to work out of the box or with a black box camera so that there's no detailed control over the device needed. You will basically provide a low light situation to the device and see how well can it actually handle it. The nice thing is about this standard is that it takes multiple aspects of image quality into account. So for many years we used like SNR10 or SNR5 as a metric to define low light performance, and you still find that in today's datasheets. But as the name suggests, that is only taking the noise into account. And of course a sensor itself will cause more noise in low light. But with a complete device, like a mobile phone with a very powerful signal processing as we have today, there will be more aspects of image quality that are affected by low light. So the nice thing is about that standard that it takes multiple aspects into account. And so how does the procedure work? So the procedure is quite straightforward. So first of all, we take a test target that is designed that way that you can measure multiple aspects of image quality at exactly the same time. So that is a multipurpose test target showing different structures that allow you to measure the important image quality aspects or key performance indicator in one target, so that the device cannot work differently. If you once take color and then measure noise in a different process, you do it exactly at the same condition. And that's important with today's mobile phones. But then you capture a reference image at bright light condition, so more than 1,000 lux to get a reference point. And then step by step reduce the amount of light. Each light level you capture an image, and these images are then analyzed for the key performance indicators. And then at the end you report as low light performance that lux level at which all aspects were still above a certain threshold. So it can happen that for one device the noise is the limiting factor, and on another device things like texture loss or exposure is a limiting factor. So, as I already mentioned too, what are the aspects that are part of the standard that define the image quality? So at first we have exposure. So if a device or an image is severe underexposed, it's too dark, so it would be considered as not acceptable. And so that is checked. It's simply checked on gray patches in a test target. And then we measure visual noise. That is a metric that takes, or noise metric that takes the perception of the human visual system into account. A very powerful metric. And I personally think highly ought to prefer over an SNR measurement because it takes the viewing condition and the human perception into account. And then we have a look at color. So devices with strong signal processing might reduce the color saturation in low light situations, because depending on the color correction matrix, you might increase noise. So to reduce noise, you might or the device might use a different color correction matrix and therefore get into issues with color. So that's also checked. And then there are two aspects that involve the spatial frequency response. That is on one side the Siemens star method to measure resolution according to ISO 12233, and the other one is the texture loss measurement based on a dead leaves pattern according to ISO 19567. So there are different aspects of image quality, and they all need to be tested in from one test target, and that is the TE42 low light. So a test chart that actually features all these patterns that are needed for that. So we have gray patches for the exposure measurement and for the visual noise measurement, color patches for color reproduction measurement as required. We have Siemens stars in the center, and we have two types of dead leaves pattern, all close to the center. So the target is designed that way that all spatial frequency response depending metrics, so slanted edges, Siemens stars, and dead leaves are arranged that way that are well close in the center, so that the field position does not affect the measurement significantly. So that's a very powerful chart to evaluate performance of a device in all light conditions, but in this case it is used for low light performance measurement. Next to a test target, you also need a powerful light source, and powerful not only in that sense that it can generate a lot of light, but also in a way that it can have a very controlled low light. So you want to illuminate the chart uniform, and you want to illuminate it with a D55, and the D55 should be a D55 in bright light, but also in low light. And there aren't that many light sources actually capable to do that. So if you take a daylight light source and dim it, you will actually change the spectral distribution of your light source, and that is can be a significant measurement error. So that's why you need a light source that has the same spectrum over different intensities. And that is, for example, or not for example, that is the IQ flat light. So a light source based on the IQ LED technology, so LED based 20-channel spectrally tunable light source, and with the latest software versions you are actually capable to turn off singular elements of the flat lights. So with that we can manage to have a range of like 2000 lux on the chart down to less than a lux on the test target, and that is pretty dim light. So it's a very powerful or very capable, let's say, light source for the low light performance measurement. And I have here some examples. I took these from a VCX version 2020 test procedure. So we have two devices that have been tested. And in the VCX test procedure, we have measurements at 10, 7.5, 5, 3, 2, and 1 lux. And you see, for example, the device on the left, we have the 5 measurements, plotted the different KPIs over the illumination level. And you see that that device actually has a low light performance of 2 lux because at 1 lux, the texture falls below the threshold. So that means at 1 lux, the texture is not acceptable anymore, or the texture loss is not acceptable anymore. So that's why the performance is 2 lux. Have a look on the camera on the right. There we see that the resolution or the exposure at 5 lux falls below the threshold. So the image is simply too dark at 5 lux. So that's why the low light performance is measured as 7.5 lux in this for this device. So I hope with this quick introduction to low light performance you have seen what you can do, how you can do that, and in particular what kind of equipment you need for that. And Yeah, as said, I think low light performance is a very important aspect of today's mobile phones. So yeah, with this way, you have a good and precise way to measure it. Thanks for watching. Bye.